Here we have a SAT math question. Okay, let's go the information. Negative x square, positive bx, negative 676 equals to 0. In the given equation, b is a positive integer. The equation has no real solution. What is the greatest possible value of b? Okay, so before we start solving the problem, let's understand our concept. Let me consider a quadratic equation in standard form, that is ax square positive bx positive c equals to 0. Okay, when I solve a quadratic equation, the maximum number of solutions or the maximum number of values I can get for this x is 2, because the degree of this equation is 2. So for some quadratic equation, I'll be getting two solutions, two real solutions, and for some quadratic equations, I may get only one real solution, and for some quadratic equation, I may not get a real solution. So how can I know whether we have two real solutions for a quadratic equation or one real solution for a quadratic equation, or no real value or no real solution for the quadratic equation? So for that, we have to find the value of the discriminant. What is the discriminant? So discriminant is nothing but the expression, that is b square negative 4ac. So here the b is nothing but the coefficient of x in the quadratic equation, and a is the coefficient of x square, and c is the constant term. So I have to find the value of this discriminant b square negative 4ac. So if the value of this discriminant b square negative 4ac is greater than 0, then we have two real solutions for the quadratic equation. If the value of the discriminant b square negative 4ac equals to 0, then we'll have only one real solution for the quadratic equation. That is, we'll be getting only one real value for x. If the value of the discriminant b square negative 4ac is less than 0, then no real solution. Okay, in our problem, the question clearly says the equation has no real solution. That means here we have a quadratic equation standard form, because this equation is exactly in the form of ax square positive bx positive c equals to 0, and this quadratic equation has no real solution. So in these three cases, which one has to be considered? We have to consider the last one. So because when the quadratic equation has no real solution, the value of this discriminant b square negative 4ac has to be less than 0. Okay, now let me take the stuff over here. But before that, we have to be knowing the values of a, b, and c. Now let's compare the given quadratic equation and ax square positive bx positive c equals to 0. What do we get for a? A is the coefficient of x square. What is the coefficient of x square in our equation? So clearly it's negative 1. So the value of a is negative 1. And now b. So what is the value of b? B is the coefficient of x. In our equation, the coefficient of b is the same b. Now c, actually c is a constant term. Constant term in our quadratic equation is negative 676. Okay, now since the question says the quadratic equation over here has no real solution, so we can consider this particular case, that is b square negative 4ac has to be less than 0. Okay, now we can plug in the values for b, a, c. So for b, we have the same b. So we have to keep this b square as it is. Negative 4 times the value of a is negative 1. And the value of c is negative 676 less than 0. And b square, when I multiply this negative and negative, it will become positive. Positive times negative will become negative. And 4 times 1 is 4. 4 times 676 is 2704 less than 0. Okay, now I'm adding 2704 to both sides. Let me do it. So then this negative value, positive value will cancel out. So I'm getting b square less than 2004. Okay, now, so to get of this square over here, I'm taking square root on both sides. So when I take square root on both sides, the square root and square will cancel out. I'm getting b less than. So the square root of this 2704 is 52. Usually when we take square root on both sides, for one of the square roots, we consider positive or negative sign. So here I don't consider positive or negative sign. I just take only the positive square root, because b is a positive integer. So when I take a negative sign for a square root, so b will be a negative integer. So I cannot consider a negative integer for b. So that's why I don't consider a negative square root. I just consider only positive square root. Anyways, I got the value of b as an inequality, that is b has to be less than 52. Okay, now let me mark this value on the number line. So b cannot be equal to 52. The value of b has to be less than 52. So we will draw the solution as like this with the empty circle over here. So I am drawing an empty circle because 52 cannot be considered. Okay, so any value less than 52 can be considered for b. No, there is a restriction given in the question, that is b is a positive integer. So any positive integer less than 52 can be considered. So the first positive integer which is less than 52 is 51. So we can consider this 51 for b, or the next one is 50. So I cannot consider any decimal value between 50 and 51 cannot be considered because b is a positive integer. Or 49. In this way, any positive integer less than 52 can be considered for b. So we can rewrite this inequality as b less than or equal to 51. So that means b can be equal to 51 or it has to be less than 51, and also b has to be a positive integer. So from this inequality, it is clear the greatest possible value of b is 51.